Hi again. So in this video we will solve another example which is a little bit more complicated. We use here a function with exponential, and we will see how to use the integral per parts. So let's take this example where x is the waiting time in hours for server to process a dataset. We defined our PDF as this, so fx equals 2 exponential minus 2x for x greater than 0. So the function is defined from 0 to infinity. So let's prove that this function actually, or the area under the curve of this function, is 1. So in the first example we saw this. This is how we find the integral or the antiderivative. But when we have exponential, it's a bit different. So we know that the integral of this function, exponential of k times x, is actually 1. What we have here, we have a is 1 now, so it's 1 over k exponential k x. For our example here, the antiderivative of this is actually minus 2 divided by minus 2, so we get minus 1, and we keep our exponential the same, so it is minus 2 over 2 exponential minus 2x, and this is our final result. Now let's replace x with the infinity, minus, which is the upper limit, minus, we replace x by 0. Let's see what this gives actually. When we replace x here by infinity, we get minus exponential minus infinity, which is actually 0. So when this tend to infinity, minus infinity, sorry, it is 0. Minus, and when x we replace it by 0, it becomes 1. This is 1, so it is minus 1. Minus minus 1, it becomes plus 1. We get 1. So this is the how we prove that our function is a PDF, or a probability density function. Now let's move to the second concept, which is the CDF. It is very important. For CDF here, as we said, we don't need to find the total area here, which means from 0 to infinity. No, but we want to find the area from the beginning, which is 0, until a specific value, which is, we call it x. So let's find the area of this function from 0 to x. We do the same thing. So here we already found the antiderivative of this, which is minus exponential minus 2x, and we replace x by x, we get this. Then we replace x by 0, we get this, which is 1. So minus minus, we get minus exponential minus 2x plus 1, and we can switch, we get 1 minus exponential minus 2x. So how can we write it here? So our fx, which answer this, px is less or equal a specific value x, it equals 0 if our x is below the lower limit, which is 0 here, and it is 1 minus exponential minus 2x if x is between 0 and infinity. Here we don't have the third situation because we don't have anything above the upper limit, which is infinity. So we have only two cases. Now it's time to find the expected value and the variance, which is the interested part. Now here for the okay, before expected value, so let's answer this question. What is the probability that the server finishes the task in under 1 hour? So we need to find f1, which means px is less than 1. What we have to do here, since 1 is within this range, so our f1 is here, we replace x by 1 and we get 1 minus 0.135, and this is the answer, so 86.5%. So the probability that the server takes less than 1 hour is 86.5%. Now let's move to the expected value. So we said that our expected value is simply the our function. We multiply it by the x, and we calculate the total area within the domain from 0 to the infinity. So when we multiply x by a function, we get this. So it's x to exponential minus 2x. Here the problem that here we have is that we have two different type of math multiplying each other. We have two functions. One is x and the second is 2 exponential minus 2x. So we cannot integrate it normally, but we need to use the integration by parts. So the rule of integration by parts is here. So the integral of u times derivative of v is u times v minus the integral of v times the derivative of u. What we do here, we choose our u or our x here, this x as u, and the derivative of v, we choose this second function. Okay, once we have our u, we can find its derivative. So the derivative of x is 1, and once we have the derivative of v, we have this. We can find v, which is the antiderivative of this one, which is minus e exponential minus 2x. So now we have u, we have the derivative of v, we have the derivative of u, and we have v. So we need just to replace all this within here. So the integral of u times derivative of v is this x times 2 exponential minus 2x. It equals, and this is what we want to find actually, it equals the u times v. Where is u here? We said u is x, times v. Where is v? V is minus exponential, so it is minus x exponential minus 2x, and it is from 0 to 8. Now minus the integral, minus the integral of what? Of v times the derivative of u. V, we have it, v, we said it's this, times the derivative of x, which is 1, times 1, and it becomes easy now. So this one is clear, so we need just to find the upper limit minus the lower limit, minus the antiderivative of this, which is 1 over 2 exponential minus 2x from 0 to infinity. Now let's replace the x here by the upper limit minus, then we replace it with the lower limit. For the first part, this one, when we replace x by infinity minus we replace x by 0, we get 0, minus when we replace, also for this part, when we replace x with infinity here, it is 0, minus when we replace it by 0, we get, for this part is 1, so 1 over 2 minus 1 over 2 minus 1 over 2, we get 1 over 2. And the conclusion here is that the expected waiting time is 0.5 hours. Now we do the same thing for the variance. So for the variance, same thing, we will apply the same thing here. So we know that the variance is e of x squared minus ex squared. What about e of x squared? What is it? Actually, it's our function times x squared. We need to find the integral from within the domain from 0 to the infinity, and we get this. So it's the integral of x squared times 2e exponential minus 2x from 0 to 8. Here we also need to do the integration by parts, because we have two different functions. So let our u, with the same formula for integration by parts, let our u is x squared, this one, and less the derivative of v is the second function, which is 2 exponential minus 2x. So in the end we get this formula. So this is what we want to find. This is it, equals u times v. Our u is x squared times v is minus exponential minus 2x, minus the integral of what, of v times the derivative of u. Derivative of u is 2x here, so it is 2 times v, which is minus exponential, so it becomes minus 2x exponential minus 2x. So here this part is already the antiderivative, but here we need to find the integral. So again we have a problem of two different type of function. We have minus 2x, or x times minus exponential minus 2x. So we need to apply the integration by parts again here. So this is our integral, how to find it. So let our u here is x, this x, while the derivative of v, we take the second function, which is minus 2 exponential minus 2x. Here our v, we can find it, which is the primitive of this. We get exponential of minus 2x, which is the antiderivative of this. Okay, so here we have our v, we have our derivative of v, we have u, and we have the derivative of u, which is 1. Okay, derivative of x is 1. So what is the this integral, which is this? It is actually u times v. U, where is u here? It's x times v. This is v. So it is x exponential minus 2x minus the integral of v times the derivative of u. Derivative of u said it is 1 times the v, our v, which is here, the exponential of it's exponential minus 2x. So in the end we get this simple equation where we need just to replace x by the upper limit and the lower limit. So for this part when we replace x by the infinity we get 0. When we replace with 0 we get also 0, so it is 0 minus. Now let's find it here. So we said this is 0, this is equals 0 minus, and for this one it is actually we replace the x here by infinity, we get 0 minus, then we replace x by 0 here, we get minus 1 over 2, so minus minus it becomes plus, so it's 0 plus 1 over 2, so this part is 1 over 2, so it's 0 minus over 2. In the end we get our integral here is 1 minus 1 over 2, 1 minus 1 over 2, and we know that what we want to find actually is this, which equals this minus this one that we found right now, 1 over 2 minus 1 over 2, so minus minus becomes 1. And let's find this part. Replace the x by infinity, it gives 0. We replace x by infinity also by 0, also it gives 0, so this part is 0, 0 plus 1 over 2. In the end we get our here integral is 1 over 2. So the final result is here, so it's 1 over 2. This is actually e of x squared. Now let's find the variance, which is e of x squared that we found right now, 1 over 2, minus the expected value squared. The expected value we said it's 1 over 2. Okay, we replace it here, 1 over 2 squared, we get in the end 1 over 4, this 1 over 4, and this is our variance. So that's how we do this with the integration by parts. Thank you for watching and see you in the next video.